Hey guys, Mr. Adamson here. This lesson is going to talk about forms of energy. And energy is the definition of it is the capacity to do work. And so we've talked about acceleration, we've talked about speed, we've talked about velocity, we've talked about force, and then we talked about work. And at the end of working with the work formula, which we know is W equals FD, we also found out that work equals energy. And so we can see right here in the definition, energy is the capacity to do work. And so through this lesson, we're going to talk about all the different forms of energy that are out there right now. And then we're going to have specific little mini lectures on potential energy, kinetic energy, and mechanical energy. Now, the first type of energy forms that we're going to talk about is chemical energy. And chemical energy is potential energy stored in the chemical bonds of compounds. Now, the key word here, potential energy. And when you think potential energy, the next word that you should think about is stored. Potential energy is stored energy. So when we talk about chemical energy, we're talking about energy stored in the chemical bonds of compounds. And you've done chemistry already, you've talked about bond energies. And so for an example of that would be the food you eat contains chemical energy that the body uses to work in the cells. So we take that food in, we break it down in our body, we break down the chemical energy in it, and it provides energy for us. Next type of energy we're going to talk about is electrical energy, and this is the work done by moving charges. So we've seen this in chemistry before too. And I mean, you just see it in your everyday life, the electrical energy that you have to run your devices, run electricity in our households and in the school. Something that really feeds into electrical energy is magnetism. And magnetism is a phenomenon of physical attraction for iron inherent in magnets or induced by moving electrical charge or current. So electrical energy really uses magnetism a lot because you get the moving magnets, which creates electrical charge, and you see that in turbines and such in different forms of energy systems that create electrical energy. Next type of energy we're going to talk about is nuclear energy. Nuclear energy is the potential energy stored in the nucleus of an atom. And when the nucleus of an atom is split, so split is nuclear fission, so split, two S's in fission, or when the nuclei of two atoms combine, nuclear fusion, so they're fusing together. This energy is released. The other one we see is solar energy, and this results from hydrogen to hydrogen nuclear fusion. So going back here, nuclei of two atoms combine, so that's nuclear fusion. So that's what we get in solar energy. And the radiant energy travels to the Earth as electromagnetic radiation and is converted to other forms of energy such as heat. And we're going to talk about here now. Actually, let's skip. Talk about here, what is heat, and how is heat and energy related? Well, if we just go down here first, heat is the transfer of thermal energy from a hot object to a cold object, and then atoms move or vibrate more quickly than in hot than in cold substances. So you can have heat transfer by three different ways. You have conduction, where you're actually physically touching something. It's going from a hot object to a cold object. You can have convection, where you have it through air currents, and you can have radiation through electromagnetic waves. Other definitions here in relation to heat and energy, you have thermodynamics, and this is a science dealing with the study of the interrelationships between heat, work, and energy. And then thermal energy itself is a movement of atoms within a substance determines the thermal energy. And we'll talk about a bit more in class the real difference between the thermal energy of something and the heat of something. And if we just go back, a couple more definitions, we have kinetic energy, and this is moving energy. So let's go moving. And so flowing water, wind, or any object in motion can be made to do work because of its motion. Gravitational potential energy is an object raised above the Earth's surface, has the potential to do work because of its position, so it's stored energy, and because of it being raised and because of gravity pulling objects towards the Earth's surface, it has that stored energy within it ready to do work. And the mechanical energy is the sum of energy of motion and position, meaning it is the sum of gravitational potential and kinetic. And now, just to get familiar with some actual abbreviations for these terms, kinetic energy is E K, and potential energy is EP, and mechanical energy is EM. And we know that EM equals EK plus EP. Now, gravitational potential, there's a difference between mass and weight when we're dealing with this, because we're also going to talk about the formulas that come into how to actually calculate these things. The previous energy forms that we talked about before, like chemical, electrical, those are just giving you some definitions about the type of energy you have there. Here we're going to get into some more of actual formulas on how do we calculate that. But first we need to know, what is the difference between mass and weight? Well, mass, which is represented by the small letter m, is a scalar quantity and is measured in kilograms. The mass of an object does not change. Objects always have the same mass. Weight, however, is a vector quantity, and it is the measure of force of gravitational attraction of an object in newtons. Now, the weight of an object depends on the acceleration due to gravity, and gravity has a constant, which is 9.81 meters per second squared. So, example, you can have a mass. Your mass is always the same wherever you are. So it could be your mass on Earth could be the same, your mass on the moon can be the same. However, your weight on Earth based on gravity and your weight on the moon based on gravity could be two different values. Now, just to do a little example here and to show you the formula, weight equals mass times gravity. And again, showing you here that gravity has a constant. The value for g, or gravity, is always 9.81 meters per second squared unless you are otherwise told. So when you're doing calculations and you have to find gravity, you're not always going to be given that within a question. You know now that it is 9.81 meters per second squared. So do a quick little calculation here. Suppose a person has a mass of 50 kg on the surface of the Earth, where the value of acceleration due to gravity is 9.81 meters per second. That person's weight would be, well, what do you want? Do you want weight? What do you have? You have gravity and you have a mass. We have our formula right here. We know that weight equals mg. Therefore, we know 50.0 times 9.81, and that would equal 490.5. Now, we look here, how many significant digits do we have? We got 1, 2, 3, this 0 being significant, 1, 2, 3. Therefore, we have to have an answer in 3 significant digits. I have an answer in 4. So what do? Well, we round this 5 up. So then we get an answer of 491. Therefore, getting your answer, if we go back, weight is represented in newtons. So our answer, therefore, is 491 newtons. Now that's it kind of for a little bit about terms of energy forms. Thanks for listening.
Made with Doodlecast Pro.